We have Kevin Banz, who is an account executive for Data Robot Switzerland and Austria. He will be giving a talk on modern applied data science automation first. Using a customer example, he will show us what success factors are crucial for any business to scale AI operations across organizations, regions, and continents. Kevin, please.
Thank you.
Welcome.
Can we shake hands?
Sure.
Yeah, great, fantastic. Okay, cool, perfect. I got tested, I'm fine. Great, all right. Let's shift gears a little bit. So thank you, Evelyn, for this very interesting topic. You actually proved a very good point, which I want to address on this first slide. Automate them first doesn't mean automate everything. It's impossible to automate everything. How are we going to automate the work that Evelyn does, right? But for Evelyn to be able to conduct the experiments that she does, there's a lot of things in prepping the data and then running the models that could actually be automated, right? So automation first, very important, doesn't mean automate everything. It means getting smarter about which things are time not so well spent for people that have the abilities that Evelyn does, right? So if we think about models as a general term, what does it take for them to be valuable, right? So one point is certainly speed of delivery, right? If you have a request to build a model and it takes you 3 years to come up with one that's actually usable, it may be that the initial request has become obsolete or has been solved in another way, right? So then application to real-world problems. It's great to solve a problem, but if it's not actually a problem for anyone else but ourselves, it's nice, but probably not as useful. And then trust from the business. In the context now of an enterprise, right? A data science team always constantly needs to prove to the business that what they've done actually makes sense, actually is accurate, right? So how do you gain that trust from the business? How do you automate, let's say, or bring to life a process that helps the business to trust the work that they don't understand, that you do understand as data scientists, but that the business doesn't necessarily understand in the detail, but understands how it was derived. And then scalability, availability, right? So solving a problem fast, solving it, obviously a real world problem, and having the business trust that you can execute on that is great. But if you can only do it once and the demand is there for it to be solved, or for similar problems to be solved 10 times, 20 times, 30 times, that also limits the value of the model. So as I said, we're shifting gears a little bit. Let's look at some successful models of the past, right? To prove these concepts. So speed of delivery, right? In the olden days, before a very important invention, it took one monk 1 year to write one book, right? That was the modus operandi for hundreds of years, even millennia, actually. And then one day, a gentleman in Germany had an idea, right? And he said, hey, we need to do this better. We need to automate this or parts of this process, right? And so we went from one monk writing one book in 1 year to Gutenberg printing the Gutenberg Bible that consists of 1,286 pages in just 5.1 hours, right? So in this process, if we compare it a bit to data science, not everything can be automated, right? He still had to prepare the type, the movable type, to make sure that in the end the result is what he wants. But once he had laid the type, once he was able to print thousands of Bibles, only applying ink to the type again, right? So speed of delivery, definitely better. There is also cost associated, right, with being faster. And in these days, people weren't paid in stock options or shares of companies. They were paid in beer, right? So we did the math, and the cost in beer for one Bible before Gutenberg was 1,825 liters. Once Gutenberg invented the printing press, it was less than 1 liter of beer. So a big, let's say, relief to many livers at that time as well, and a huge gain in productivity, right? And the source for that is actually the documents from the cloister Alpirsbach in Germany. So it's 5 liters of beer a day was the allowance of a monk, one of the monks that would write the Bible, right? So speed of delivery. Then application to real-world problems. The steam engine, right, revolutionized the world. Or did it? This revolutionized the world. The steam-powered locomotive. Once there was a real-world application for the steam engine, we went from, an interesting but kind of useless invention to, something that catapulted humanity into the industrial era, right? So really being able to take what we've learned, what we've invented, what we found, and then convert it to that real-world problem. That's what instills value into a model, into anything. Then trust from the business. I've heard it saying a few times before, and I think it's right for certain things in life. The things I can trust most, or even harder expressed, I can only trust things that I built myself, right? Well, I mean, the brothers Wright, they built their plane themselves. It's revolutionary. It was the first plane, right? They were the first people to actually leave ground in a plane that they had built themselves and landed safely, right? But if we think about, where we are today with United Airlines just ordering 15 of new supersonic planes that, will be making Mach 1.7. The question of trust is who, in which plane would you rather have your boss sit to fly across the Atlantic, right? So depending on the relationship you have with your boss, but I would say most of us would probably rather have him or her sit in the boom supersonic, right? Again, right, build ourselves, great, not build ourselves, but we get what it does and we can trust that it will do what it's designed to do. And then the last concept that we want to touch on before we start applying that to what it means in the life of, or can mean in the life of data scientists, is the topic of scalability and availability, right? So the first car that was patented was the Banz Patent Motorwagen, right? It was fascinating because it ended the era of carriages, right? It ended the era of transportation relying on horses. But the Ford Model T was what really brought the automobile to the masses, right? And the reason for that was the moving assembly line that Henry Ford invented, right? So both basically were cars, we can say, right? But from the Banz Patent Motorwagen, there were 25 units built. And from the Ford Model T, there were 15 million units built, right? So also there, the attempt to automate something that can be automated in a process brought a huge increase in value. Now, if we look at a bit more concrete what that could mean, right, for data science, how to move from left, from that great invention, from this discovery, to right, to really industrializing it and making it valuable and useful to the business, there's a few things, right, to think about. So a typical process, looks like this. So you need to gather data. Okay, now, when you gather data, you need to find the right data. You need to document that data. You need to link it to sources in code, right? So then you need to prepare that data that you've gathered. So, writing custom code for data transformation is not unusual. Rerunning data processing many times, rebuilding data sets per project, right? That's something that's time consuming. Maybe not something that, the brightest people in the world should be doing. Maybe something we could automate, right? Then feature engineering, every time you derive a feature, you need to document that feature. There's things, involved like ethics, unwanted bias, etc. in models that we need to tackle, that we need to document to make sure that if we put our model into production, that we're not going to get ourselves in trouble, right? I mean, the most well-known examples of, bad models in production are obviously what happened with I believe it was Apple with their sexist credit card application process, where basically women were being discouraged to sign up, or they would be automatically filtered out. And then Amazon, right, where the AI that they used to screen CVs would suddenly become, biased in a very bad way. And these are things we don't want to happen, right? We need guardrails. We need to make sure that we tackle these things early on. And we need, if we want to do it at scale, we need software to help us do it. We can't do it all manually. It's just physically impossible. And then comes the point that we've just learned in Evelyn's talk, that we maybe don't even want to automate, right? That's about model creation and validation. We want people, real people, working on these models, understanding these models, analyzing them, and then sort of giving the stamp of approval of a human, right? Before we take the model out and then let it do what it does best, process tons of data in a very fast time, right? So that's certainly one part we would not look to automate. But then once the model is deployed, right, or even going to model deployment, if you're not in a vacuum, if you work for a large company, you will have to speak with IT. There will be guidelines how you can deploy it. You'll need, to possibly get integrations with apps and with other infrastructure. So there's, it's not always a very straightforward process, depending on the infrastructure of the company, obviously, right? And then once we have the model running and in production, then it's about monitoring, right? So in an ideal world, we would not just deploy the model and just let it do what it does. We would want to know if we have things like data drift, if we have model drift, if there's something happening that should compel us to take action, right? And then once we have tackled all of this, we're still not quite there, because the business is going to want to know, how do I quantify the value that this provides to me, right? We're not doing this as a fancy exercise. This is supposed to provide real world value, right? So we're again back to explaining, the value of the model, making sure we can translate from a scientific language into a business language. And only then do we arrive, at value where we're able to build trust, gain more funding, hire more colleagues, be able, to take our endeavors in data science further in the company, right? So yeah, we could say the line from data to value is not always very straightforward in this scenario. Now, if we think about, what could a Gutenberg press look like in that sense? We should think about, is there a way that we can build a team around a central place, central platform, place, infrastructure, whatever you want to call it, where we can assure standardization, governance, compliance, and orchestrate a federated data scientist team. Data scientists that don't sit in the central data scientist team, but sit in the departments that are familiar with the particular use cases in these departments, with the particular data that they're working with in these departments, and thereby leveraging, let's say, a shared service center with best practices, with excellence, with security, with governance, right? Making sure we don't build Skynet inadvertently, and but at the same time, don't slow that process down and sort of start to bridge these gaps and barriers that we have today. I mean, a good example is, if you look at the big job sites today, there's 2.9 million job openings worldwide for data scientists. There's about roughly 1 million people to fill these jobs, right? So it's hard to find the right people, the good people. So the goal has to be, as always with scarce resources in a market economy, to do the most we can with the resources that we have. And doing the most we can with the resources that we have means my data scientists focus on really bringing data science to every corner of the business, and don't focus on things like data prep, on monitoring, on writing documentations, etc. Right? Then what a journey to apply data science can really look like is, or a good way to go about this, let's put it this way, is, you start on the left with single AI use cases. You think about, and probably all of you are there, not probably, all of you are definitely there. You choose the right model, you work on its accuracy, and you deploy, right? But then going forward, you want to do that more than once, right? So when you start doing things more than once, you will identify areas where you see, hey, some things are always the same. Not the same data necessarily, but the process is always the same. So how can we develop an approach that we can test, for example, prototypes very fast, don't have to spend time on documentation, and just really become leaner and nimbler in data science operations, right? Make that time, from data to value shorter. And then once we're sort of at that point of the AI maturity curve, it's about integrating data science, right? So as you've seen on the slide before, the Gutenberg press kind of, right? You're able to centralize core operational functions, right? So certain things are always standardized. They can be pulled as a service out of there. You know, it speeds the process up a lot. You have proper governance in place. So you know and you're sure that in case of audits, in case of regulatory requirements, you're always able, you know, to deliver an answer on what your models are doing and how they're doing it, and what you're doing to mitigate, you know, unwanted consequences or unwanted symptoms, right? And then sort of the end game out of that is the AI-driven business, right? Where you have a level of trust established within the business where people know what I get from my data science department, from this core operation is reliable. I can use it, and I can embed it into apps. And that's really where we have a lot of conversations with many clients in Switzerland at the moment. It's really about that journey to becoming that AI-driven business. How do I make sure that, you know, I can have my centralized function, and I can have that in Switzerland, for example, and I can have a business unit in Japan, knowing exactly what they get from there, and then start to consume that data without having, you know, logging requests, building custom reports, but really having that embedded. Every time data changes, every time something in the model changes, having that automatically updated. I think AI at one point will live in every app that we use, just because it's super useful. And you know, automated machine learning or applied, you know, data science through automated machine learning can absolutely be one crucial step to get there. Again, it's a journey. Everyone in this room and online is at a different step in this journey, but we believe this is kind of a good way to think about, you know, where this journey can go, and in the end, you know, what it can be of use. And obviously, I mean, being that AI-driven business, I think goes without saying, is going to be that next big advantage, right? It's very similar to when electricity was invented, or the steam engine, as we saw before, right? The first one to come up with a railway company, you know, would outbeat their competition by far. And data has that potential as well, probably even more than electricity had at the time, or the steam engine. So with that, I am at the end of my presentation. Again, we tried to show a way how to get faster from data to value. I hope it was interesting for you. Thank you all for taking the time to listen to me today. And with that, I say thank you.
Thank you very much, Kevin.
Thank you.
Nice talk. I've been following Data Robot for a while, so let's see if there is some questions from the audience. Otherwise, I might have a few actually. The virtual side. No questions. So could you maybe give us an example of one or two use cases that, you know, where Data Robot has really helped the companies in driving some good ROI from the projects?
Yes, absolutely. Absolutely. So, I mean, what's interesting with these platforms is there's so many areas of application, right? It's actually anywhere in the business where you're trying to improve something, there's an ML use case sitting there, right? So one that I really like, that's also very exemplary of situations in Switzerland, is with CVS Pharmacy in the US, right? So they had a huge backlog of ML projects that they wanted to get off the floor. So lots of requests from the business, also pretty mature business leaders that understood what they could get out of ML, but just that bottleneck they had, and they already had 300 data scientists on the team. But when they realized with Data Robot, they can go from only leveraging these 300 data scientists to including the 2,000 business analysts that were all working with the data that would, you know, eventually be used by these models, they were able to just speed up and really bring down that backlog. So I think a big part is really what, you know, the catchphrase for this democratization, right? And I'm not a big fan of that democratization word, because I think it's a bit overused. But I think when we talk about data democratization, it definitely makes sense. So it helps people come closer together, because you have analysts that understand their data, and you have data scientists that understand the models. And if you have a platform that they can work together on that is guarded with governance, with guardrails, it's just a completely different ballgame, right? It goes from, again, data scientists doing tasks that somebody else could be doing and focusing on the high value, high impact use cases.
High value. Thank you very much. So in that, do we have any questions? No? So perhaps my last question would be then, you mentioned business analysts and this pharmacy, that could put in 2,000 employees suddenly onto your platform and then to create more value from the data. What role does culture and education play in getting used to new systems like Data Robot? How does that come into picture?
That's a very good question. So culture is obviously important, right? Because it requires transparency. Mm-hmm. And what we've seen, with a lot of Data Robot customers is that people that never thought that they would have a career in data science actually got a career in data science because they were exposed to it, right? It wasn't, the silo where you have the scientists that work, isolated and the business people working isolated. But because they moved closer together, you could see, very talented people in, let's say, the business analyst area, mm-hmm. then move over to data science because they just showed a lot of talent. So it's basically it's a community, a place to come together within the company. And again, with the proper guardrails, right? Mm-hmm. So making sure that everybody does things that are actually valuable and actually contribute and doesn't break anything, right?
True.
And so
thank you very much again for the nice presentation. I'm a total pro of using such tools because I think the power to play with data should be given to, if possible, every individual in the world. Yeah. Thank you very much.
That's again. Our mission. Thank you.
Thank you. We have something for you here.
Thank you. Appreciate it.
For you to remember this event. Thank you very much for joining us.
Thank you very much.
I wish you all the best with Data Robot.
Thank you very much.
Thank you.
Thank you.